This is the video for SOL 6.12 or Congruence. You'll need one pencil and one highlighter, preferably yellow, to complete these notes. Make sure you listen, pay attention, and pause before you copy. Now if I have two line segments, when the lengths of those two line segments are the same measurement, then these are called congruent segments. So line AB with a line over it, and line EF, and this symbol shows that line AB is congruent to line EF. Now when angles have this degree measurement that are the same, so angle C is congruent to angle D because angle C is 110 degrees and angle D is 110 degrees, then we have congruent angles. So when segments are congruent, they have the same length or measurement. When angles are congruent, they have the same degree measurement. Now for shapes, when all corresponding sides and angles, or sides and angles that match up, have the same measurement, an exact copy that can be flipped, rotated, or slid, but never stretched or compressed. So if I could flip or rotate these and they will match up on itself, then these are examples of congruent shapes. Now not all of those shapes are congruent to each other, just the ones in those boxes. Now we're going to color in all shapes in each problem that are congruent to each other. And you can use a ruler to help you verify or make sure that they are the same shape and the same size. So here we have 8 side, 8 side, 8 sides. So we have a bunch of octagons, and then over here we have a 6-sided hexagon. Now this octagon is way too small, so that one's not going to be congruent because it's not the same shape. The hexagon wasn't congruent because that wasn't the same size. And if I measure the sides of these hexagons, it looks like they're each about 5 centimeters long. So if each of those sides are all 5 centimeters long, and each of those angles look like they are the same size as well, and one is just tilted a bit to the side, they're the same shape and size, just in a different rotation. And those two shaded yellow octagons are congruent. Now for number 2, we see a bunch of parallelograms. So they all have the same basic shape. Let's measure the long side of the parallelogram because it looks like the opposite sides are congruent. So I have 10, 15, 16, 17. It looks like we've got about 17 centimeters for that shape. And this parallelogram on the bottom looks like it's about 25 centimeters long. So we'll have 25 for the long side of this parallelogram. And so far that looks like it's too big. And for this parallelogram, the longer side is about 17 centimeters as well. Okay, so 15, 16, 17, we got about 17 centimeters on the long side of this parallelogram. And then we've got 17 centimeters on this long side of this parallelogram. So those 3 parallelograms, the long side is 17 centimeters long, and then this fourth one down here is 25 centimeters long. So that one's way too big. Now if we measure the short side, we got 10 centimeters. This one, the short side, is 10 centimeters. And this one, we've got 10 centimeters again. So for each of the short sides, we have 10 centimeters. So each of the long sides match up. Each of the short sides match up. And we can kind of see that the opposite sides are congruent as well. So these 3 are congruent and the fourth one's not. If we take an outline and we kind of rotate it and slide it around, and we see that it matches up on top of each of those other angles, then we see that all the angles are congruent. And we also see that all of the sides are congruent or the same length. So I could flip, slide, and rotate that shape, and if it falls back upon itself, then it's going to be congruent. All right, for question number 4, we see that we have a bunch of pentagons. They each have 5 sides. Now, number 3, they're the same shape, obviously, but they're also the same size. Number 4 over here, they're all pentagons, but this one's too big. This one's flat. They're not the same size. The two smaller ones end up being the same size and the same shape, just turned a little bit. All right, for question number 5, we can measure the longest side of each of these quadrilaterals. They don't have a special name to them. They're all just quadrilaterals because they have because they have 4 sides. Sorry, 5 sides is a pentagon. Bad, Miss Bansky. Okay, so the longest side in this one is 20 centimeters long, and you can kind of look at whichever the longest side is, and we have 20 centimeters for this quadrilateral that has 4 sides. And we can measure the longest side here, and we get 20 centimeters again. So we have 20 centimeters for the long side of each of those quadrilaterals, and then this last one definitely looks a lot bigger, and we can see that it is much bigger, and since the long side's much bigger than the longest side of any of the other ones, that can't be congruent to any of the other quadrilaterals. So let's look at the side that's across from the 20 centimeters. I get 10 centimeters here, I get 10 centimeters here. Across from this, ooh, I got like 12 centimeters on that one. So I have 10 centimeters that's across from the 20, 10 that's across from the 20, and then 12 that's across from the 20. So that one doesn't match up with the other 2 that I've got so far. And I'm spinning that around, and that looks like it's 10 across from the 20 centimeters as well. Now, in between the 10 and the 20, I can kind of see that each of those shapes, those 3 shapes that are remaining, that's about 10, and the other side's about 15. So this shape, I have 15, and I have 10. So those 2 shapes are congruent. And then double checking this last one, I have 10 and 15. So some of these shapes are just rotated or flipped, but those 3 are actually congruent. I would take this one and I could rotate it around a few times to get some of these other shapes, or flipped to get that last shape on the right. For number 6, we can look at the different shapes, and this one definitely looks like a parallelogram, and the other ones, quite a few of them look like they are shorter than this parallelogram. This one looks a little too wide. This one looks like it's much smaller than everything else, and this one looks like it's almost got right angles. It almost looks like a rectangle, and the angles being too wide, like much wider than the acute or much smaller than the obtuse. Okay, it looks like they're all almost 90 degrees, and that doesn't look like it for any of the other shapes. And here, these look like all 4 sides are congruent. And then this one, it looks like those 2 sides are congruent, but then these 2 sides are congruent to themselves. So I have 2 pairs instead of sides that are congruent. And if I kind of copy and paste that outline and move it around, I kind of see that those 3 are congruent. And that last one didn't have all 4 sides the same size like these 3 that I'm shading in. So these 3 shapes are actually congruent. Now these lines, if I look here, that is about 25, and this one is about 25 as well. So this is 20, like 24, 25 centimeters. So they're each about 24 centimeters, and we're going to say that these lines are congruent because their measurements are the same. For number 2, we're looking at the lines. So we're looking at the lines, and we're going to measure this one, and we're going to measure this next one, and we see that those definitely do not have the same measurement. So this one, the first one was about 22 centimeters, and the second one was about 31 centimeters. That's not the same, so they're not congruent. They do not have the same measurements. So we're looking at lines, then we're looking at the ruler. Okay, for question number 3, it's asking about the angles. So even though the lines are the same size, we're not using that. We want to use the angle. So here, 50, 60, 70, kind of off the screen a little bit, but we have, when we actually measure those with a protractor, this first angle was 70 degrees and the second angle is 50 degrees. So the angles don't have the same degree measurement. So if I'm looking at if the angles are congruent, I want to know if the degree measurement is the same or not. Okay, this one you can't quite see what the first one was, but this one is 45 degrees, and the first one was actually 45 degrees as well. So each of them has a 45-degree angle. Now the lines are definitely not the same size, but these angles are congruent because the angles each have a congruent or equal measure. If I have the same shape, but I can tell which one's big and which one's small, they are not congruent. Here, I have two shapes that are each six-sided. So I have 6 sides on each one. They are each hexagons, and I see this hexagon has 10 centimeters for all of its sides all the way around. So I have 10, 10, 10, 10 all the way around. And we've got 10 and 10 here. We've got 10 and 10 here. And it's looking like this hexagon has sides that are 10 centimeters long all the way around, and it looks like those angles are all the same. So these two shapes are congruent because all of the angles that match up and all the sides that match up are actually congruent. For number 7, I see that each of these 4 angles are right angles, and I'm looking here. So I see all 4 of the angles are the same, and if I measure that, it's looking like all of the sides are about 15 centimeters long, and each of the sides here are also about 15 centimeters long. So it looks like all the sides will match up and all the angles will match up. So these two squares are congruent because all 4 of these sides match up with all 4 of those sides, and we can say that they're congruent. Now these shapes, I see that these two sides right here, just looking at them, are congruent, but then the sides opposite of that, I see that this is about 15 centimeters, and then this one is a little over 20 centimeters. So these are definitely not congruent because if I flipped that over on itself, the 15 centimeter side and the 22 centimeter side wouldn't match up. So these two shapes aren't congruent. If I look at this star, there are 5 points on the star, and this one has 6 points on the star. So if I have 5 points and then 6 points, it's not even the same shape and it's not congruent. Now, question number 10 is a little more difficult. It's a word problem that's saying color in the quadrilateral. So the quadrilateral, there's only one answer that appears to have 2 congruent angles. It doesn't say more than 2. It doesn't say 2 pairs of congruent angles. It just says only 2 of them are congruent. So this is kind of implying that only 2 of them within the same quadrilateral should be congruent. Now, in this first shape, we see that we have an acute angle, like a very acute angle. And then this one is acute. This is an acute angle, but it is just a little less than 90 degrees. So the first angle was definitely acute, and then this one is a little less than 90 degrees, and so is this. It's really close to 90-degree angle, a right angle, like a square angle, but not quite the same. And if I see this one, it looks really close, really close to a square angle as well, but this one is a little more than 90-degree angles. So it doesn't look like any of these angles so far within the same quadrilateral are congruent, what I'm looking at so far. This one right here is definitely acute. So it's not even close to the other acute, because that one's closer to 90 degrees. And this one's definitely obtuse. It's much more than 90 degrees. So nothing in this quadrilateral is going to be equal. The two acute angles are definitely not even close, and the two obtuse angles are not even close. Now, that quadrilateral's just, it doesn't have any angles that are congruent. In this quadrilateral, it looks like these two obtuse angles are pretty close to being congruent. We can measure them to be a little bit sure, but it looks like these two obtuse angles are congruent. If we look down at this parallelogram, these opposite angles look like they're congruent. We've got the opposite acute angles that look to be exactly the same, and we could verify that by measuring with a protractor. And this parallelogram has a lot of congruent stuff, but we wanted only two congruent angles. We didn't want two pairs of congruent angles. So that's why that one doesn't quite work. And for this last quadrilateral, it looks like everything's just slightly off. These two obtuse angles at the top should be congruent, but it looks like one is closer to 90 degrees than the other. So those two are not quite it. It looks like it's tilted off to the side. And these two acute angles, this one's really close to 90 degrees, and this acute angle, if you draw a right angle, it looks like it's much further away from being 90 degrees. So it doesn't look like those two are quite right either, because they're just not exactly equal. They look closer or further away from 90 degrees. Now, for the first quadrilateral in the top left that I'm looking at now, this one is the one that I'm going to color in because it has exactly two angles that are congruent, and then the other ones are not. For number 11, it says that Nikki drew a sketch of the floor plan of her home, so you can look below at the picture to find that. Which two rooms in Nikki's sketch appear to be congruent? Right now, looking at the dining room, that is smaller than everything else. It doesn't look like the same size or shape as anything else. So anytime you see the dining room, like here in answer choice G, you can get rid of that as an answer choice. Now, if I look at bedroom 2, bedroom 2 has this little piece that is skinny. And the living room has a little piece that comes off of it as well, but that's much more fat. So the living room and bedroom 2 look like somewhat similar shapes, but whenever we see the living room and bedroom 2, we can get rid of those. And then, so answer choice J is definitely not correct either. And the dining room for answer choice H is too small to be congruent to anything else. So it looks like G, H, and J don't really work, and you don't have anything congruent. So if I look at bedroom 1 and the family room, I look at the long side and the short side, and then I match the short side up here, and I get 10 centimeters, and the long side up here, and get about 21, 22 centimeters. And I see that bedroom 1 and the family room, the long sides match up, the short sides match up, and it looks like they're both rectangles. They are the same shape with the same angles, and they are also the same size. And that's why answer choice F is the best answer. For question number 12, it says figures L, M, N, P, Q, R, and T, U, V, W, X, Y, the order that we say that is important, are congruent. Which line segment in figure TUVWXY must be congruent to LR? So if I'm looking at this, LM, MN, NP, PQ, QR, and then R back around to L, written in that order. We have TU, then UV, then VW, then we have WX, XY, YT, so Y back around to T. So if I'm looking for LR, LR is the sixth set of letters, and that kind of matches up with the T and the Y. But we want to make sure that we're going around in the correct direction. So we said L first, and we said R second. So that's going to go towards the fifth set. So we're going to go towards the fifth set, and we have TY is the segment that matches up with LR. So the order in which they're said is important.